Have you ever pondered over what will happen to Alpha Centauri in the next 4.5 billion years? It's a question that sparks the imagination, leading us into the cosmic realm of the unknown. Alpha Centauri, our neighboring star system, is closer to us than any other in the cosmos, a mere 4 light-years away. This celestial trio, composed of Alpha Centauri A, Alfa Centauri B, and the red dwarf Proxima Centauri, spins its own dance through the universe. As our sun's life cycle progresses towards its inevitable end, we are drawn to consider Alpha Centauri not just as a celestial curiosity, but as a potential future home for humanity. Exoplanets have been discovered orbiting these stars, stirring our curiosity and ambition. As we gaze upon the stars, we can't help but wonder about the future of Alpha Centauri. Stars, much like us, have a life cycle. They are born, they age, and eventually, they die. This cosmic dance, however, unfolds over billions of years, in a time frame far beyond human comprehension. Our story begins in dark, cold, molecular clouds, vast regions of space brimming with dust and hydrogen gas. Within these clouds, pockets of gas begin to collapse under their own gravity, forming dense cores. These cores heat up, and when they reach a high enough temperature, nuclear fusion ignites. A new star is born. This is the infancy of a star, a time known as the main sequence. Stars can remain in this stage for billions of years, steadily burning hydrogen in their cores and radiating energy into space. Our own sun, a middle-aged star, has been in the main sequence for about 5 billion years and is expected to stay there for 5 billion more. As stars age, they start to run out of hydrogen fuel. They begin to burn helium, causing them to expand and cool down, transitioning into what we call a red giant. In this phase, stars can engulf their surrounding planets as they continue to expand. Eventually, the star exhausts its nuclear fuel. What happens next depends on the star's mass. Stars like our sun will shed their outer layers, creating a beautiful nebula while leaving behind a white dwarf, a dense hot core. Larger stars, however, meet a more dramatic end. They explode in a supernova, leaving behind either a neutron star or, if massive enough, a black hole. For Alpha Centauri, its future is as fascinating as its present. Containing 3 stars, 2 similar to our sun and 1 smaller red dwarf, the system's fate will be a spectacle to behold. As they age, these stars will transform, shifting stages, and eventually meeting their cosmic end. But that's a story for another time. For now, let us appreciate the beauty of stars in their prime, shining brightly in the vast expanse of the cosmos. As time ticks away, Alpha Centauri will undergo significant changes. In the grand stage of the cosmos, nothing is static. Each star, including those in the Alpha Centauri system, is on a journey of constant transformation. In the next 4.5 billion years, these celestial bodies will evolve, with changes in their size, temperature, and brightness. To understand how Alpha Centauri will change, let's delve into the life cycle of stars. Stars are born from clouds of gas and dust, and over billions of years, they burn through their nuclear fuel, eventually swelling into red giants. After shedding their outer layers, what remains is a super-dense core, a white dwarf. Now imagine Alpha Centauri A, also known as Rigil Kentaurus, the most luminous of the trio. Over the next 4.5 billion years, it will exhaust its nuclear fuel, swelling into a red giant. Its size will be colossal, its brightness dazzling, and its temperature will drop as it expands. Likewise, Alfa Centauri B or Toliman will follow a similar path. However, being slightly smaller and less massive than Rigil Kentaurus, Toliman's transformation into a red giant will occur somewhat later. Its size, brightness and temperature will also change, but not quite as dramatically as its bigger sibling. But what of the red dwarf, Proxima Centauri? Red dwarfs are slow burners. They can last trillions of years, far longer than their more massive counterparts. Proxima Centauri, in 4.5 billion years, will likely be much the same as it is today, quietly burning away in the galactic backwaters. In the grand scheme of things, 4.5 billion years is but a cosmic blink. Yet the changes during this period will be profound. The trio of stars we know today as Alpha Centauri will transform, each in its own way and at its own pace. The transformation of Alpha Centauri will be a spectacle to behold, a testament to the ever-changing cosmos. As Alpha Centauri changes, its exoplanets will also face their own destinies. Alpha Centauri's dance through the cosmos is not a solo performance. Orbiting this celestial trio are exoplanets, worlds that exist outside our solar system. As the stars of Alpha Centauri evolve, the fate of these exoplanets will be directly influenced. Just like the planets in our solar system, these exoplanets are tied to their stars. The life cycles of Alpha Centauri A, B, and Proxima Centauri will dictate the conditions of their respective planets. As these stars age, expand, and eventually die, their planets will experience dramatic shifts in climate, atmospheric composition, and even physical structure. For instance, if a star swells into a red giant, as our sun will in its twilight years, it could engulf nearby planets or strip them of their atmospheres. This would render those planets uninhabitable, at least by our current understanding of life. On the other hand, if a star shrinks and cools, it could potentially freeze its planets into icy wastes. Yet it's not all doom and gloom. These changes could also give rise to new life forms adapted to survive in the harsh conditions. Life, as we know it, is incredibly resilient and adaptable. After all, it has thrived in some of the most extreme environments on our own planet, from the scorching heat of volcanic vents to the frigid depths of the Antarctic ice. Moreover, the death of a star is not always the end. It could lead to the birth of new stars and planets, providing a fresh canvas for evolution to paint its masterpiece. Hence, the changes in Alpha Centauri could potentially pave the way for the emergence of new worlds and possibly new forms of life. The fate of these exoplanets is not sealed. Their future, much like ours, is a cosmic dance, dictated by the rhythm of their stars. Change, even on a galactic scale, is not to be feared but embraced as a natural part of existence. The fate of these exoplanets is intertwined with the future of Alpha Centauri. Alpha Centauri's story is not just a tale of the future, but also a tale of the past. Around 4,500 years ago, when the pyramids of Egypt were rising from the sands, our ancestors looked up at the same stars we observe today. They aligned these colossal structures with celestial bodies, creating a connection between the Earth and the cosmos. Alpha Centauri, though perhaps not known by that name then, was part of this stellar tapestry, silently bearing witness to the birth of human civilization. This creates a fascinating link between the ancient world and the future of space exploration. The same stars that were once used for navigation and timekeeping now hold the promise of new worlds and potential homes for humanity. As we look upon Alpha Centauri, we are not just looking at a star system but a piece of our past and a glimpse into our future. The cosmos is a vast, ever-changing tapestry, and Alpha Centauri is but one thread in it. As we've journeyed through the enigmatic world of Alpha Centauri, the closest star system to our own, we've delved into its present state, speculated on its future, and even traced back to its past connections. Today, Alpha Centauri, with its trio of stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri, stands as a beacon of potentiality and curiosity. We've explored the life cycles of stars and how these celestial bodies over billions of years transform, evolve, and eventually meet their end. Such is the case with our own sun, which in about 4.5 billion years will exhaust its nuclear fuel, leaving humanity in search for a new home. And who knows? Perhaps the planets orbiting Alpha Centauri might just be that haven. The exoplanets of Alpha Centauri, currently in their own dance around the star system, could be the future abodes of humanity or other life forms. The movements of these stars over long periods could impact these planets, just like Earth has been influenced over millennia. We've also touched upon the fascinating alignment of stars with Earth's historical landmarks, such as the pyramids of Egypt, around 4,500 years ago. These ancient connections remind us that our fascination with the stars is not a recent phenomenon, but a deep-rooted interest embedded in our history and culture. The future of Alpha Centauri remains an enthralling subject, teeming with unknowns and possibilities. It's a testament to the fact that our universe is not stagnant, but a dynamic, ever-evolving realm of cosmic drama. But as we ponder on these possibilities, let's take a moment to appreciate the celestial spectacle that we are a part of, right here, right now. The stars that twinkle in our night sky are not just distant points of light but stories of cosmic evolution unfolding in real time. As we continue to explore the cosmos, we must remember that the stars we gaze upon today will change, just as Alpha Centauri will in the grand theater of time.